This video is Integrated 3, Chapter 10, D-Day number 3. So on this first problem, we are giving it a series to find the sum of the first 7 terms. This is arithmetic because when we look at this equation, this is arithmetic. And for an arithmetic sum, it is S sub n is equal to n times the quantity a sub 1 plus a sub n all over 2. Now, in this case, my n is going to be 7. My a sub 1, if I substitute 1 into the equation, is going to be 139. My a sub 7 is going to be 111 plus 28 times 7. So 111 plus 28 times 7 is 307. So now let me substitute that in. So S sub 7 is going to equal 7 times my first term, which is 139, plus my last term, my 7th term, which is 307, divided by 2. And that is going to be equal to 1,561. That is the sum. On number 2, this one is slightly different for 2 reasons. First off, it is geometric because of the equation. Let's move this a little. Secondly, I am not starting at the first term. I'm starting at the 5th term. So I'm going to do the 5th, 6th, 7th, 8th. That's 4 terms. That's what I'm going to be adding. Now, you want to know how to figure that out without having to list them out. So you take the last term you want minus the first term you want, and you always are going to add 1. So 8 minus 5 is 3, 3 plus 1 is 4. And you see it was 4 terms. That's how you figure out how many you are summing up. Now for this geometric situation, S sub n is equal to your first term. I'm going to write a sub 1 here temporarily, times the quantity 1 minus r to the n all over 1 minus r. Now, in this case, my first term is not my a sub 1. My first term is actually going to be a sub 5. So that's what I'm going to start with. And my n is not going to be 8 like up here at the top. It is going to be 4. So I am really going to be finding S sub 4 is equal to my 5th term, which is the first one they want me to do, 1 minus, and my r in this case is what I am raising to a power. So my r is going to be 1.5, okay? Times 1.5 to the power 4 all over 1 minus 1.5. Now I need to find my 5th term. And to find the 5th term, I'm going to put 5 in. So I am going to put in 5 into this equation, okay, to figure out my 5th term. So I am going to find a sub, there's a different color here, do it in orange. So this is not my S sub n, this is my a sub n. I'm going to find my 5th term. It's going to be 24 times 1.5 to the 5 minus 6, or to the negative first power. So I'm going to go in my calculator, 24 times 1.5 raised to the negative first power. And I get that my a sub 5 is 16. So that is what's going to go into this spot right here. I am going to get 16. So I'm going to work this out. I'm going to put this into my calculator. And I end up getting 130 for my answer. On 3, given the series 116 plus 79 plus 42 plus ... write that series using summation notation. So in this case, I need to figure out if it's arithmetic or geometric. If I was to take 79 and subtract 116 to see if it's arithmetic, 79 minus 116 gives me a negative 37. Let me then take 79 and see if when I add a negative 37 on, okay, if I get 42, and I do. So this is going to be arithmetic. Okay, this is going to be arithmetic. And my common difference is going to be a negative 37. And when they want us to write it in summation notation, I need to find the equation to generate these numbers, 116, 79, 42. So I'm going to start with 116. I am minusing 37. Because this is my first term, this is going to be n minus 1. So now for the summation notation, I am going to start with 1, and they have ... up here. So I'm going to go to infinity because it doesn't give me an end point. And then I write my a sub n. 116 minus 37 times n minus 1. And that's your answer. On the next one, number 4, this time we are again starting with 116. I obviously am not adding this time. So this one's going to be geometric. So I'm going to see when I'm multiplying 116 by to get 371.2. So I'm going to take 371.2. I am going to divide it by 116 to see what I get. So 371.2 divided by 116 is 3.2. Let me just double check and make sure that if I take 371.2 and I times it by 3.2, I get that. So when I put that in my calculator, I did end up getting 187.84. So my R is going to be 3.2, and this is geometric. So then I need to find my a sub n. So my a sub n is going to be 116 times 3.2. And again, because this is my first term, this is going to be an n minus 1. So when I write this in summation form, this is going to start n equal 1 to infinity because they gave us ... And the equation is 116 times 3.2 to the power n minus 1. And that is your answer. So on number 5, this time we want to find the sum of the first 18 terms. And looking at this looks like I'm subtracting 6 each time. So that's going to be my D. This is going to be arithmetic. And if I am trying to figure out the sum of the first 18 terms for arithmetic, the formula is n times my first term plus my last term all over 2. So I know my n is 18 because they want us to do the first 18 terms. I know my a sub 1 is 82. I see it in the series here. I need to find a sub 18. So in order to find a sub 18, I am going to come up with an equation. So my 18th term, I would take 82. I'm going to be minusing 6, 18 minus 1 times, because this equation would have been 82 minus 6 times n minus 1, and I want the 18th term. And when I put that into my calculator, I end up with a negative 20. So I get a negative 20. So that's my a sub 18. So now when I come to do this equation, I am going to have s sub 18 is equal to 18 times 82 plus a negative, but I'm just going to write it as a minus 20 all over 2. And so when I do that, I end up getting 558 as my answer. On 6, this time, this one is looking like it might be geometric, because I'm definitely not subtracting the same amount each time to get from 5,625 to 2,250. So I am going to figure out 2,250 divided by 5,625. If I take my second divided by the first, I'll see what I'm multiplying by. So 2,250 divided by 5,625, I end up with 0.4. That is going to be my R. So my R is going to be 0.5. This is geometric. So if this is geometric, I am going to be using S sub n is equal to my first term times the quantity 1 minus r to the n all over 1 minus r. So when I substitute this in, and I want to find the 11 for some of the first 11 terms, my first term is that 5,625. 1 minus my r is that 0.4 to the power 11 all over 1 minus 0.4. Put that into my calculator. And when I do, I ended up getting 9,374 point, let's say 61 if I'm rounding. Okay, so this wasn't like a nice clean answer. It's going to be about that. Now on B, they want us to find the infinite sum. Okay, we find infinite sums for geometric, but only if our R, so for an infinite sum, it has to be geometric, and my R in absolute value has to be between 0 and 1. And since this case, my R is 0.5, this qualifies. If my R was not in between 0 and 1, I'd say that an infinite sum does not exist. It would either just go to infinity or just go to negative infinity. It wouldn't go towards a limit. So the formula for a infinite geometric sum, S is equal to A1 over 1 minus R. So in this case, my S is going to be 5,625 all over 1 minus 0.4. And so when I put that into my calculator, I ended up with 9,375, which you see, this is getting closer to when I raise it to 11. So it's going to get closer and closer and closer and closer and closer as I get bigger and bigger and bigger, bigger amount of terms that I'm adding. to 9,375. Okay, on the next page, on number 7, in this case, this one we're ending at a particular term. We need to figure out what this is. Noticing that this has decimals, I'm thinking it's probably geometric, because otherwise I would have been getting decimals earlier in this problem. So I'm going to take 1440, the second term. I'm going to divide it by my first term and see what I'm timesing 800 by. And I end up with 1.8. 1.8. So that's going to be my R. Okay. And again, this is going to be geometric. So they want us to know how many terms are in the series. So I want to write an equation for a sub n. And a sub n is going to equal 800 times 1.8 to the power n minus 1, because that 800 is my first term. Now, I want to figure out what term that one is. When I say that one, I mean this one right here. So I'm going to substitute that in for my a sub n. And I'm going to have 800 times 1.8 to the n minus 1. I'm going to divide both sides by 800. So when I divide by 800, I ended up getting 34.012224. I'm going to keep that number in my calculator. I'm not going to round it, so that if I do round it, I'm not going to get a nice answer. Now I need to find the exponent. So that means I'm going to use logarithms. So really, I'm going to do log base 1.8 of 34.012224 is equal to n minus 1. And when I do that in my calculator, I end up getting 6. So I get 6 is equal to n minus 1, which means when I add 1, my n is 7. So it is my 7th term. Okay, 7th. Or so in this case, there are 7 terms. How about I say that? 7 terms in this series that we're adding. So now they want us to find the sum. So to find the sum of a geometric series, it's going to be S sub n is equal to the first term times 1 minus r to the power n all over 1 minus r. So I am going to be doing S sub 7. My first term again is 800 times 1 minus, and my r was 1.8 to the power 7 all over 1 minus 1.8. And when I put that in my calculator, 800 times the quantity 1 minus 1.8 raised to the power 7 divided by the quantity 1 minus 1.8, I ended up with 60,222.032 as my answer. So on number 8, on this one looks like this one's probably arithmetic. So I need to figure out what, if I take my second term, which is a negative 396, and I subtract my first term, I am going to see that I am adding 141. That is going to be my D. And again, this is going to be arithmetic. So I'm going to go through kind of the same process I did in the other one. How many terms are there? So to figure out how many terms, I'm going to do A sub n is equal to negative 537. I am adding 141 n minus 1 times. Okay. Now I want to figure out what term this one is. So I'm going to put in 1014 for my A sub n. I get negative 537 plus 141 times n minus 1. I'm going to add 537 to both sides. And I get 1,551. I'm going to divide both sides by 141. And when I do that, I end up with 11. And when I add 1, I get 12. So this is 12 terms. So now in the next one, I want the sum of these 12 terms. So I'm going to be doing S sub n is equal to n times my first term plus my last term all over 2. So in this case, when I am doing this, I am going to be having S sub 12 is equal to 12. My first term is that negative 537 plus my last term is 1,114 all divided by 2. And when I work that out, I ended up with 2,862 as the sum. So on number 9, they want us to find A sub n. I know that, and they tell us that this is geometric, okay? So A sub n is going to equal, and I am going to start with this term, which is my third term. So I'm going to go to 20,808 times some r, not sure what that r is. And it is going to be raised to, okay, it's going to be raised to the power n minus 3. And the reason it's a 3 is because that is my third term. So now I am going to take this term and stick that in for my A sub n. So I'm going to have 817,837.632, write that whole thing, is equal to 20,808 times r to the 6 minus 3. So first off, let me just rewrite this. Since that's a 6 minus 3, that's really going to be r to the third. So now I'm going to divide both sides by 20,808. So 817,837.632. I'm going to divide it by 20,808. And I end up with 39.304. Again, keep that decimal, don't round it. Now to solve this, I'm going to take the cube root of 39.304 to get my r. And I ended up with a 3.4 for my r. So now I'm going to write the equation using this format, starting with my third term. Okay, so I'm going to have A sub n is equal to 20,808. We are timesing it by 3.4. And again, since this is my third term, this is going to be to the n minus 3. And that's going to be our equation. On 10, similar idea, but this time it's arithmetic. So I am going to be doing a sub n is equal to, and I am going to be starting with this term, which is my 8th term. So negative 56.6. We're adding some d, not sure what it is, and that's going to be n minus 8 times because I'm using my 8th term. Then I am going to take this 17th term, put that in for my a sub n, so negative 212.3 is equal to negative 56.6 plus d times 17 minus 8. So let me just clean that up real quick. So when I do that, I'm going to end up with 17 minus 8, which is 9. So I'm going to get a 9d. I'm going to add 56.6 to both sides. So I'm going to take a negative 212.3, and I'm going to add 56.6. And I get a negative 155.7. Sorry, 0.7 is equal to 9d. I'm going to divide by 9, and I get a negative 17.3 is equal to d. So now, for my equation, again, I am going to use the one that I had with my 8th term. So I'm going to go a sub n is equal to, starting with my 8th term, which is negative 56.6. I am minusing 17.3 and minus 8 times, because again, this was my 8th term. And that's our equation. So on number 11, we are going to expand this. I'm going to draw Pascal's triangle to the row that has a 1, 3. Okay. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. So again, I want to do it to the row that has a 1, 3. Okay, that's where I am. So now what I'm going to be doing is I'm going to have 1 times 4x to the 3rd, and I'm going to just change colors here, plus 3 times, and this time my 4x is going to be to the 2nd. Notice it was the 3rd. It's going to go down 1. And then I have a negative 7y. And these exponents here, the 2 and the exponent for my negative 7y, have to add to that 3. So that's going to be to the power of 1. And then I'm going to use this 3. So that's going to be plus 3 times 4x, this time to the 1st. And my negative 7y is again going to be 1 plus what gets me 3? 2. And then my last one is going to be plus 1 times negative 7y to the 3rd. And then we're going to work each of these out. So for the first one, it's going to be 4x to the 3rd. Well, 4 to the 3rd is 64. So that's going to be 64x to the 3rd. Anytime I have a minus in my binomial, it's going to be alternating signs, because this one here to an odd power will give me a negative. This one here to an even power will give me a positive. And then this one here to an odd power is going to give me a negative. So I get alternating signs. Okay, so now for the purple. I'm really going to be doing a 3 times 4 squared, which is 16, times a negative 7 to the 1st, which is just negative 7. So 3 times 4 squared, which is 16, times a negative 7, and I get a negative 336. My x is raised to the 2nd, my y to the 1st. My next one, I'm going to have a 3 times 4 to the 1st, which is 3 times 4, and a negative 2nd squared, which is going to be a 49. So I'm going to have a 3 times 4 times a -7 squared, which I'd want to put it in parentheses around that -7 and square outside if I'm doing it in a calculator, plus 588xy to the second. And then my last one, -7 raised to the third, is a -343 y to the third. And that is going to be my final answer. On number 12, we're going to be doing a binomial probability here. It says find the probability that you get a red light exactly 4 times if you drive down Melrose and face 11 stoplights. So we have 11 trials and we want kind of like 4 times that we're getting this red light. It is equally likely that you get a green, yellow, or a red. So be careful with this problem. I don't care about the probability of a green and the probability of a yellow. I care about the probability of not red. So if they're all equal, each one of these would be 1/3, 1/3, 1/3. Okay. So the probability of a red light is going to be 1/3. The probability of not a red light is going to be the rest, which is 2/3. Okay. That's what we want. Red light, not red light. So we want 11 times we've hit a stoplight. Choose 4 times that it's red. Okay. And so the probability of a red is 1/3, and this is going to be to the power 4. And the probability of not a red is 2/3. And that is going to be, when we do this, we take this exponent plus this exponent has to equal that number. So if 4 of them are red, that means 7 of them are not red. And we're going to put this into our calculator. And when I put that in, 11 choose 4 times 1/3 to the 4th times 2/3 to the 7th. I ended up getting 0.2384, let's say, approximately, as my answer. And that's the end of this video.